Good evening, everyone. Um, I guess it's going to be only me today, and that's all right. I will solve few questions today based on week seven's lectures, and you can always view it in YouTube, uh, or maybe some students will join soon. If you have any doubts on today's topic that I'm going to discuss, you can always mail me, or you can also come to next class. I think next class is going to be last class or last problem solving session. Maybe there will be one more class for revision. Okay. Yeah, this is an 8-week course, so it is going to end in a couple of weeks. All right, we have one student. Okay. Anyway, um, let's first just quickly go through the this week seventh lecture. It's going to be on numerical integration. Um, Let me check my recordings before that. So it is going to be on numerical integration. Um, so what we did till now was we studied about numerical differentiation, how to differentiate a function, and we saw different methods on how to differentiate that. Now, the next step is naturally is to what are the different ways to integrate a function, uh, especially when the function is really hard to integrate. Not all the functions can be easily integrated. Um, so, for example, there will be certain functions which you do not have an antiderivative, so you cannot directly integrate it. You may need to go to an extent of the various methods to integrate it. And also, given that you have a definite integral, in which, like, if you want to evaluate a function within a certain um, limits from a to b, that can be easily done using numerical integration, provided you take enough data points in between a and b. Okay, so that's what we saw in this week about what are the different various methods to solve numerical integration, especially definite integral. So a definite integral is nothing but an integral of a function uh, whose limits are known, whose limits are from a to b. Okay, so let's say this is your f of x is your function, and you are you wanted to integrate from x naught to xk. Okay, that's the definite integral. Now, what we saw till now is we can always approximate a function to a polynomial. So in this case, f of x can be approximated as p of x. So when you do an integration, you can always integrate this polynomial to get the definite integral. Okay, and one of the polynomial that we saw was Lagrange polynomial. We also saw Newton's forward difference, Newton's backward difference, Newton's central difference. So all of this, using any of this method, you can construct a polynomial, and you can substitute. And integrating a polynomial, we all know it's very easy. So you can easily integrate the polynomial, and you can evaluate the uh, polynomial, integrated polynomial in those limits to find the integral. Okay, so that is the first step. uh, Provided the function, you can approximate the function to a polynomial. In this case, you can approximate as a Lagrange polynomial. If it's a Lagrange polynomial, you need to just integrate the Lagrange coefficient and multiply that with the data points. And similarly, you have a Newton's forward difference. Newton forward difference, again, you can simply boil down to this simple equation where you have to integrate the entire forward difference formula with as a function of p, and then you will be able to arrive at the integral. Okay, and there is also the error of integral. There is also error of integral. You can always based on this order, you will be able to find out what is the order of the any method. Okay, so that was the first step. First step is based on whatever we know till now. So given a function, you can approximate it as a polynomial, and you can always integrate that polynomial to get the integral. So that is the first method. Now the later methods that we saw was given the function without going through all the polynomial construction and then integrating, what are the other ways? What are more simpler ways that you can follow to evaluate the same integral? So the first one was rectangular rule, where, so if this is your function, this is how it varies in x f of x graph. If this is how it varies, if you want to find the integral from a to b, integral is nothing but the area under the curve, right? So area under this curve, evaluated, if it is evaluated with respect to dx, then area under this curve bounded by the x-axis. So the area under this curve is what we call it as integral. Now we know that this is how the curve is going to vary. So the rectangular rule is nothing but you just divide it into small chunks and then make it as a rectangles. And once you make it as a rectangle, we know, so the rectangle, we know the rectangle's dimension. This is f of a. This is f of the f of a into x naught minus x1. Similarly, f of x1 into x2 minus x1. F of x3 into x3 minus x4. Similarly, you can continuously do that, and f of x minus 1 into x n minus 1 minus xn, or the other way. Okay, and then you add all of them. That will be your rectangle rule. Okay, so all these data points, if it is given, you can do it, or if you know the function, you can always substitute all the x1, x2, x3 to find y's, and this will be your simplest integral, where the integral can be written as h is nothing but your uniform divisions that you take, multiplied with all the y. So y of 0, y of 1, y of 2, y of 3, y of 4, y of 5, y of 6, y6 and y7. In this you have 7, but you can always divide it into n intervals. So that is your first method, and the later methods are you can define as a quadrature rule, where you are trying to uh, given given certain f of x, or given certain coordinates, or you call it ordinates, um, you can always assign some weights to all these values to get a good approximation for your integral. But if we don't know the weights, we need to find the weights, and the method that you follow to find the weights will actually lead you to different set of methods. So first thing is you have this Newton Cotes formula. So for let's go in this order. So you what you have to do is you need to find, given the f of x naught and f of x naught pair. Okay, you can assign lambda 1, lambda 2, lambda 3 as weights, and if you assign it as 1, then this becomes a simple rectangle rule, given provided that, I mean, if you assign it as h, all the lambdas, if you assign it as h, then it becomes a rectangle rule. And now you can also assign the lambdas in a intelligent way, and when you do that, you will end up having different set of formulas, and that's what we saw in the entire uh, like 3-4 lectures, last 3-4 lectures, right? So, and the order also, you can, error you can find out, and its order you can find out. So the this is what we call it as Newton Cotes quadrature formula, and for a you know uh, equally spaced h, f of x naught, f of x naught plus h, x naught plus 2h till x naught into n h, you can always find lambda naught, lambda 1, lambda 2, and lambda 3. And so the first method is trapezoid rule. The trapezoid rule is like simple extension of rectangle rule. In rectangle rule, we chose a rectangle, but in trapezoid rule, what we are going to choose is we choose a trapezoids. So which means the top end is going to be a linear line between f of x1 and f of x2 for this rectangle. Okay, or basically in this, let's say you take this one, you take this rectangle. So now instead of taking this as your area, if you, let's say, take this, then this is a trapezoid, it's not a rectangle. And now this so this part was missing in the rectangle rule, but now since you have updated with the trapezoid rule, what happens is you will be able to minimize the error. So basically you will also take this area into consideration, so your error will be less. Okay, so that's the point. So the trapezoid rule will become simply like this. So for the, if you take the entire interval, then this is your trapezoid rule, and the other one is composite trapezoid rule, which we just saw. we just divided from A to B, we divided into n data points, and then this is your trapezoid rule. We all know the derivation. You can check in the lecture notes. So this is your trapezoid rule formula. If you substitute all these data points in this formula, you will get a more better estimate of integral. Similarly, there was and this also tells, the error term also tells that as you increase the number of data points that you take, your error is going to reduce. So that is natural. That's what we have been doing for the whole numerical methods. If you increase the number of data points, your error is going to reduce. So the same thing is what we can also see here. In Simpson's 1/3 rule, we take instead of, so what we did here, instead of rectangle, we choose a triangle. Sorry, we choose a linear line at the top. Now instead of that, you take 3 points and then you fit a parabola, quadratic polynomial. That becomes your Simpson 1/3 rule. Okay, so basically you approximate it as a parabola of degree 2 for every 3 points, and when you do that, this will be your Simpson's 1/3 rule for the entire range A to B. uh, if the function is complex, you divide it into small divisions, and then you can use a composite Simpson rule, which is you know nothing but is also a function of all these data points. Okay. And then we also have Simpson's 3/8 rule. It's just an update of 1/3 rule, which is instead of taking 3 data points and fitting a parabola, you take 4 nodal points and approximate it as a cubic polynomial. Okay. Um, so which means for this you need 1, 2, 3, and 4. So for each data point you need four nodal points, and you fit a cubic polynomial for each 4 nodal points, each set of 4 nodal points, and then you will end up having this equation for uh, composite Simpson's 3/8. Okay. So it's just an update from rectangle rule we started. We approximated a straight line, and then we now we changed it into linear equation, and then parabola, and then cubic polynomial. That's the thing. Okay. And then we went into something called Gauss legendary integration rule, which is, all these are like quadrature method. So till now we followed certain uh, what do you call certain logic, like we approximating, dividing and approximating it with different uh, you know uh, curves. Here what you're going to do is, you're for Gauss legendary integration rule, we are going to identify what are these lambda 1 and lambda 2, lambda 1, lambda naught, lambda 1, lambda 2, lambda 3 to till lambda n, depending on what should be our depending upon our order of accuracy, we will have to choose lambda naught, lambda 1, lambda 2, and also x naught, x1, and x2. Okay. And once you choose it, and then you can you yourself you can construct a uh, quadrature rule, and you can integrate them. So that's the basic idea. So it gives you more freedom. So you no need to you no need to restrict yourself with what are the data points I should consider. So for example, in the previous all these rules, what we saw, the entire data point is evenly spaced, like h, or yeah, basically h everywhere. But here you have some flexibility, x naught, x1, and x2, you can choose however you want. Okay. So here we are going to see the special case is a Gauss legendary integration rule, and it is applicable only to an interval of -1 to 1. And the first 1 point rule is, you are going to choose only 1 point. Using that, we are going to integrate a function. So when you do that, um, there is you have lambda naught and f of x naught, but you don't know which point you should choose, and what should be your lambda naught, or what should be your weight, right? So for that, we have to make some approximation to that function. So let's say if that function has to behave exact for two kinds of function. One is, if it is 1, it has to be exact, and if it is x, it has to be exact. So if that is the condition, if you put that condition, then you will end up having this as your integral, this as your integral rule. Okay. Similarly, you can go for 2 point rule. Let's say 1 point is not enough. I want to go for 2 points. Then again, you impose certain function that it has to meet, and once you substitute them in the rule, then you will end up having the 2 point rule. So that 2 point rule is going to be simply f of minus 1 by root 3 and f of 1 by root 3. Okay. So this is your simple 2 point rule. Similarly, you can do for 3 point rule, you can do for 4 point rule, however you want. But we stopped at 3 point rule. The 3 point rule, the function integral rule is going to be something like this. Okay, we will solve one or two problems in this thing, and also this is specially applicable only when you're uh, you know uh, the limits change from -1 to 1. Now, if your limit is from a to b, then you have to do some transformation. The transformation should be in a such a way that a becomes -1 and b becomes 1. Okay, and one such transformation is this one: x is equal to half of b minus at and b plus at, and you integrate for t. So whatever the integral function that you get for this, that will be your integral for integral of f of x dx. Okay, we will solve one problem in this so that it will be very clear. I hope this is just a quick recap of what we did. If you have any questions, please stop me anytime. So today I have uh, a little more problems. Today I have like 6 problems to solve, because all these are like simple problems which you just need to substitute in the formula, and you will get the answer. Okay. All right. So yeah, as I usually used to say, uh, feel free to stop me anytime if you have any doubts. So without further ado, let's jump into this week's problem. The first problem is, I think this is kind of like an application based problem. So where you have a canal, and the canal is considered to be 40-meter wide. So total width of the canal is 40 meter, um, and the depth of the canal at every at at different distances is what they have uh, reported here. The depth of the canal at a distance from one bank is given by the following tabular data. Bank is nothing but sides of the canal. So from one side of the canal to the other side, they have recorded the depth. Okay, let's say this is your canal. From one side to other side, this is like 40 meter. So they have used probes to record the depth. Okay, so this is like here, let's say this is in z direction. Okay, they have used probes to record the depth, and this is what they have, and this is what they recorded data. Now based on this, you need to find what is the cross sectional area, or basically what is the so let's say the side view or whatever the view it is. So let's say this is how flow is going to flow, and this is what they are asking: what is the area, cross sectional area of the uh, this canal. So basically, again, the same thing, we just need to integrate this the table that they have given. Okay, so here they are measured only for like every 5 meters, but in reality people usually measure for every few centimeters, and currently you have like 1 2 3 4 5 6 7 8 9 data points. But in general you will not have just 9 data points. You might have like 50,000, even 1,000 data points you will have. And then you need to integrate the entire data point to find the cross sectional area. And we need to find cross sectional area to avoid uh, you know uh, how to also to understand what is the capacity that a canal can hold, the water flow, all these things. Okay, so This is the question. We have some set of data x, y. So the mathematical question is we have x, y table that they have given, and we need to find. We need to use Simpson's 1 by 3 rule to find the integral of y. Okay. So I is nothing but integral of 0 to 40 y of x dx. I don't know why this is. One second. Now this is much better. So I is integral of 0 to 40 y dx. So this is your area. And we are going to use Simpson 1 by 3 rule. And what is Simpson 1 by 3 rule? Simpson 1 by 3 rule. And yeah, of course, it's a composite 1 by 3 rule because we have multiple data points. So that is nothing but h by 3 into y naught. Here we wrote it in terms of f of x naught. I'm just going to write it in terms of y naught. 4 into y1 plus y3 plus every alternate points dot 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 plus y within 2 and minus 1, correct? Yeah, plus 2 into y2 y4 y6 plus y2n minus 2 plus y of 2n. This is the Simpson 1 by 3 rule, right? So in this case, what are your, so let's just write it in terms of y naught. So this is your y naught, this is y1, this is y2, this is y4, this is y5, y6, y7, and y8. So total you have like 9 data points, and y ranges from 0 to 8. Okay. So if that is the case, you just need to write this as, and what is h? H is you can write 5 minus 0, which is 5 meters. So this is going to be 5 by 3 5 by 3. You have only 9 data points, so let me write down again the Simpson rule for this 9. Y naught plus 4 into y1 y3 y5 and y7. You cannot write y9 because that does not exist, so y7 plus 2 into y2 y4 y6. We should not write y8 because that's the last data point, so it has to come outside y8. So the first and last data points cannot be within this 4 or 2 functional forms. All right, this is your Simpson 1 by 3 rule for this problem. That is going to be 5 by 3, y naught is 0, 4 times, what is y1, 2.5, 3.75, oh no, sorry, 4.5, 6.25 plus 3.25 plus 2 into y2, 3.75 plus 5.75 plus 5.25, and finally you have 0.5. Okay. All right. So that's it. You just need to find area. What is the area? So if you guys find out, please let me know. So it's 0 plus what is this coming out to be? It's not calculated. 2.5 plus 4.5 plus 6.25 plus 3.25. 16.5 into 4. So this is coming out to be 66. So please cross check my calculations. 3.75 plus 5.75 plus 5.25 into 2. This is coming out to be 29.5 and this is 0.5. Okay. How much is this? 29.5 plus 66. This is 96 into 5 divided by 3. So I'm getting something like 160. Since it's an area, all these are given in meters, so it's 160 meter square. Okay, this is the cross-sectional area of the canal. So this is Simpson's 1/3 rule, which is what is being asked. So maybe, let's try Simpson's 3/8 rule also, so that you will be comfortable with this approach. So let's say if you want to do Simpson 3/8 rule, what will you do? So let's get back to the formula. I mean, it's easy to remember. 3/8 is already there, which means it should be 3h/8 into y0 and y8 is, uh, first and last point, so that will be separately written, and the other point should be, I think it's 3 times y1 y2, or maybe first I will write the entire equation so that it will be easy to understand.
Excuse me, sir.
Yes.
Sir, Simpson 3 by 8 is applicable only for multiple of 3 interval. So how can you apply this method in this interval, because it is even number of interval, 8 interval, there are 8 interval. So I think it is not possible to apply 3 by 8 rule, right?
3/8 rule, I see. Okay, so it is applicable only for
Multiple of 3 interval, 3, 6, 9, 12, like that interval only it is applicable.
right. Okay, yeah. So this is not, you do have 9, right?
I think interval 8
Oh,
only, no?
interval is 8. Okay. Okay.
Yeah,
Okay. Yeah, that's right. I didn't notice that. Yeah, you're right.
okay.
Yeah, maybe if we have one more interval, then we can do it.
Yes, it is possible. Okay.
Okay.
Thank you, sir.
All right, great. Thank you. We don't need to solve this. Any other questions?
Nothing, sir. Okay, you
Okay.
can proceed.
All right. Yeah. So, oh, 1 second. What happened? Oh, I, accidentally deleted the first page. Okay, anyway, I will update it while I post this. But yeah, as Damodaran said, I think you cannot apply for this 8 intervals. So we'll stop there. Now we will apply Simpson's 3/8 rule for this function. Okay. So now I think this also, again, there is some mistake in my questions. Okay. So now I have given an integral which is from 0 to 1.5, 2x by 1 plus x square dx. Now we want to use the Simpson's 3/8 rule to check whether, to find out this I. So before that, let's also try to find out in, easiest way, the analytical way, because the function is already known. Here the function is 2x by 1 plus x square. So how can we integrate this? You can use the transformation of variable, where you can choose t to be 1 plus x square, and differentiation is going to be 2x dx. So now you can substitute this as, so I is going to be 0 to 1.5 2x plus 1 plus x square dx. You can replace that as in terms of t, which is dt by t. While you do that, you should also change your limits. So here the limits, when x is equal to 0, your t is going to be 1, and when x is equal to 1.5, your t is going to be 1.5 square is 2.25 plus 1 is 3.25. Okay, so this is going to go from 1 to 3.25. All right, now integral of 1 by t is natural log of t, natural log of t, and it has, you can write it as 1 to 3.25, and natural log of 3.25 minus natural log of 1. Natural log of 1 is 0, so natural log of 3.25 is how much? 1.1787 is what I get. No, 86. 1786. Okay, is this fine? Now this is the analytical method, but that's not what we want. We need to, you know, use Simpson's 3 by 8 rule. So let's do that. For that, we were asked to take 6 intervals. If that is the case, how do we do it? So first we need to construct the table first. So it's going to be f x and f of x, and f of x is 2x plus 1 plus x square, and the interval is 0 to 1.5. So what should be your h? So 1.5 minus 0 divided by 6. So it's 0.25. So now let's do that. So 0, 0.25, 0.5, 0.75, 1, 1.25, and 1.5. 1, 2, 3, 4, 5, 6. Okay. Now you have 6 intervals, and f of x is going to be, h is 0.25, and let me write down here, f of x is 2x by 1 plus x square. This is the function we want to integrate. So for 0, it's going to be simply 0, and for this is going to be 0.25 square plus 1, 2 into 0.5. This is going to be 0.4706. So if I make any mistakes here, I am not going to get answer, and luckily we have the answer for it. Should be somewhere near this. Okay, and hence if I make any mistakes, please let me know. 0.5 square is 1 divided by this is 0.8. 0.75 square plus 1, 2 into 0.75 is 0.96. This 1 plus 2 by, oh, why am I doing this? This should be just simply 1. 1.25 square plus 1, 2 into 1.25. This is 0.9756. 1.5 square plus 1, 2 into 1.5. Answer is 0.9231. Okay, so these are your tabular data points. Now what we need to apply, we need to apply Simpson's, remember this is a composite Simpson 3 by 8 rule. Okay, which is 3h by 8. Where is it? Yeah, 3h by 8 f of x naught plus 3 times f of x1, f of x2. You continue it till f of x 3k, actually 2 3, okay, that's why they didn't put 3k minus 2, 3k minus 1, 3k minus 2, f of x 3k minus 1, okay, and plus 2 into f of x3, all the say all the 3 6 multiples of 3 data points, you need to just add them here. F of 6 plus dot plus f of x into 3k minus 3. Here it's minus 3 because uh, the 3k is going to be your final data point. Okay, is that correct? Yeah. So this is your Simpson's 3 by 8 rule. Now we need to write it for this function that we have. So this is going to be f of x naught, f of x1, f of x2, f of x3, f of x4, f of x5, and f of x6. All right. So here, let me write it for this form, for this problem. That is going to be f of x naught plus 3 into, you have um, x1 x2 and x4 x5, okay, and you have only x3 as so your 3k is 6, so k is 2, right? Yeah, k is 2, so it goes from f of x1 f of x1 and f of x2 plus 2 minus 1 is 5 till 5, so and then f of x4 and f of x5, okay, and your k is 2, so 6 minus 3 is just 3, so you will have only 2 times f of x3, okay, let me write it in normal way, f of x3, and the final one will be simply f of x6. All right, now you have h to be, what is your h we already found is 0.25, so let's substitute them here. 3 into 0.25 divided by 8 into f of x naught is 0 plus 3 into 0.4706 plus, sorry, 0.8 plus 1 plus 0.9756 plus 2 into x3 is 0.96, and finally you have x6 to be 0.9231, 0.9231, okay. Now let's evaluate this. This is 0.75 by 8, so this part is going to be, the second term is going to be 0.4706 plus 0.8 plus 1 plus 0.9756 into 3. So the second part, so 0 plus 9.7386, 0.96 into 2, 1.92 plus 0.9231. So how much is this? 0.9231, 9.7386 is 12 into 0.75 divided by 8. This is 1.1795. Okay, I hope this is right. So 1.1786. Okay, we are slightly over predicting. So the real answer is true value is 1.1786, and the Simpsons 1 by third rule is 1.1795. So it's up to like second decimal it is accurate. Okay. All right. Any questions? So in numerical integration, it's going to be just straightforward application of formula. Okay. I hope there is no question here. So sometimes your integral can overpredict. Also, please check this value. It should be uh, correct, but please check this value. And also sometimes your integral can overpredict, because whatever you integration that you're doing, you're going to do it along a certain um, let's say your curve varies like this. Now when you're trying to match with a parabola, in this place, let's say for example, if you take and if you try to match with a parabola, uh, you might slightly go up, or in this place, let's say you're trying to match with a parabola, it might go something like this. So these extra areas will get added up, and this could happen. Okay. All right. So if there's no questions, let's move forward with question 3. So question 3 is slightly interesting. It has nothing to do with you know finding integral. I mean, it has to do with finding integral, but it tests your formulas. For example, you have an integral of 0 to 2 f of x dx. It is evaluated using both trapezoidal rule and Simpson's 1 by 3 rule. Okay, and the value obtained was 16 and 12. Okay, when you do trapezoidal rule, your value was 16, and when you do Simpson's 1 by 3 rule, your value was 12. Uh, then using the above information, we were asked to find f of 1. Okay, which is in between f of in between the limits from 0 to 2. All right, so let's try to do it. Integral of 0 to 2 f of x. So please note that we don't know the function value. Okay, and if you are applying Simpson's, so what is the trapezoidal rule? So the trapezoidal rule is there is here your a is 0 and b is 2. I mean, your integral is from a to b. Now the trapezoidal rule is, if we go back, this is our rule, right? But this is for one interval. Okay, so what is our rule? B minus a by 2, sorry, b minus a by 2 into f of a plus f of b. Okay, this is for one interval. Okay, and similarly Simpson's 1 by 3 rule, Simpson's 1 by 3 rule cannot be done with one interval. It has to be done with two interval. So for that, what you have is p minus a by 6, or what, h by 3. You can also do h by 3, but here I'm just going to go with b minus a by 6. Both are same formulas. F of a plus 4 times f of a plus b by 2 plus f of b. Okay, but this is for two interval. Okay, they didn't say how many intervals they took, but when they are evaluating it for two methods, they have to do it for same number of intervals. So what we are going to do is, we are also going to assume two intervals for trapezoid, because for trapezoid it can be done for any number of intervals. So I'm going to rewrite this for two intervals. and I'm going to write it as integral trapezoidal. Okay, this is integral Simpson. Simpson integral. Okay, for trapezoidal rule, if you want to write it for two interval, how will you write? So that is going to be initially it's h by 2. H is nothing but b minus a by n. So b minus a by n, and n is 2 because it's a 2 interval, so it's going to be simply 4. Okay, and inside you have f of a and f of b, and the other things will be inside 2 times f of a plus n, or a plus nh, which is here f of a plus b by. Okay, so this is basically a plus nh, and a plus n, a n is 2, h is b minus a by 2. So a plus, okay, wait, a plus 1h, right? A plus h, a plus b minus a by 2. This is a plus b by 2. Okay, so that's what I simplified and wrote it. So this is for two interval. Okay, and so we know that I traps is what do we say, 16. This is 16, and I sim is 12. This is what we obtained, right? Yeah. So now you just need to substitute these relations, and you just need to eliminate f of a and b. You will end up having, so for example, a is 0, b is 2. So um, this is equal to 2 minus 0 by 4. 2 minus 0 by 4, which is nothing but 1 by 2. So I'm just going to write it as 1 by 2, and f of a will keep it like that, or a is 0, so f of 0 plus f of 2 plus 2 into f of a plus b by 2 is 1, f of 1. Okay, and this is equal to b minus a is 2, 2 by 6 is 1 by 3, so I'm going to just write it as 1 by 3. F of 0 plus f of 2 plus 4 times f of 1. Okay, now f of 0 and f of 2 is present in both the equations, so you just subtract them. So what it is going to be, so you can write it as 24 is equal to f of 0 plus f of 2 plus 2 f of 1, or you can also write this as, I'm just going to equal to 2 f of 1. Okay, and the second equation is going to be simply 36 is equal to f of 0 plus f of 2 plus 4 f of 1. Now I substitute this here. This becomes f of 0 plus f of 2 plus 2 f of 1 will become simply 24 minus f of 0 minus f of 2 plus 2 f of 1. Okay, so this part is 2 f of 1. So f2 f of 1 plus 2 f of 1 is 4 f of 1. I just substituted it here. So what this does, this basically you can cancel these. So f of 0 and f of 2 goes away, so you no need to really know f of 0 and f of 2, and there is also no way to know that, right, because there is no function given. So this becomes 36 equal to 24 plus 2 f of 1, and this can be simplified as 2 f of 1 is actually, how much is this? Is this correct? It's
18 into
24.
16,
It's
32,
32.
sir, right? Okay.
Okay,
Yeah.
great. I am very bad in math. So if you substitute 32 here, 36 minus 32 is 4. So f of 1 is 2. Okay. So these are like, I mean, this test So the whole point of this question is not to do integration, but to test whether you know trapezoidal rule or Simpson's rule, whether you have good understanding of it or not. These kinds of question you can expect in some competitive exams maybe. Okay. All right. I hope it's clear. It's very simple. So if there are no questions, I'm going to go to the next question I have. So the fourth, this is fourth. Okay, we have three more questions. So in this question, what we are going to do is we are going to again use trapezoidal rule for n equal to 4, and we are going to find out integral of 0 to 1 f of x dx is given. So it's same like our previous question. We don't know the function, but the function values are given. So for example, let me explain you the question. Suppose f of 0, f of 0.5, f of 1 is given, and f of 0.25 and f of 0.75 is alpha, so that is not given. And what they are given is they are given the integral value. So if I use a trapezoidal rule and integrate this table, I will end up having my integral value to be 3. Now what we were asked to find is what is this alpha that will give you 3. So if I want to simplify this question, I can write it like this. So you have x and you have f of x, and x varies as 0. I'm going to write it in ascending order: 0, 0.25, um, 0.5, 0.75, and 1. And for 0 it's 1. Okay, and for 0.25 and 0.75 it's alpha, so I'm just going to write this 2 as alpha. And for 0.5 and 1 is 2.5 and 2. This is 2.5 and this is 2. Okay, and you have like 4 intervals, which is also right. You have 4 intervals. Okay, we were asked to find this f, and now if you use trapezoidal rule, here, it's going to be h by 2 into f of x naught plus 2 times f of x1, f of x2 plus f of x3, and finally you have f of x4. Correct? So this is your f of x1, f of x2, f of x3, f of x4, f of x5. Okay, you have till 5, so this has to be updated. Plus f of x4. All the internal points will be multiplied with 2, and all the boundary points will be substituted separately. All right, so this is h by 2, correct? 1, 2, 3, 4, 5. Oh wait, we usually start with x naught. F of x naught, f of x1, f of x2, f of x3, and f of x4. So whatever I wrote before was right. So some textbooks start from 1, some textbooks start from 0, so it's always in confusion. Okay, now h is going to be 1 minus 0 by 4 intervals, so it's going to be 0.25, which is what we have, so that is also fine. So let's just substitute it, and this traps is going to be the integral is, this is equal to 3. Okay, so now you just need to substitute it and solve for alpha. So here it's going to be 0.25 by 2 into f of x naught is here. Okay, f of x naught is 1, and 2 times f of x1 is alpha, 2.5, and alpha plus x4 is 2, equal to 3. All right, so this is going to be 1 plus 2 times 2.5 plus 2 alpha plus 2 is equal to 326 by 0.25, which is 64, which is I think 24. Yeah, this is equal to 24. Now this is going to be 3 plus 5 plus 4 alpha equal to 24. So 4 alpha equal to 24 minus 8, I think 16, and so alpha is equal to 4. Okay. Yeah. Yep. All right. So sometimes these kinds of questions also can come. They will be asked to find out what is the data point. You just need to know the formula, and it's so there are like only few formulas. If you know the logic, you can easily do this. Okay. All right. Now we have a different uh, function here. Again, we are going to find integral uh, in this problem also. So the function here is simple. Simple in the case it's explicitly given. Here the function is, I think there should not be another dx. Sorry. So the function is 1 by 1 plus x squared. So let me write that down. So f of x is 1 divided by 1 plus x squared, and the integral is from minus 1 to 1 f of x dx. Okay, this is what we need to find out. They were asked to find out this. By the way, the previous one was choose the best answer, so which is 4. So now we need to find this integral from minus 1 to 1 using Gauss 2-point formula. So we know that Gauss legendary integration rules will apply only if your limits vary from minus 1 to 1, and here it does vary from minus 1 to 1. So the question itself has given that the limits vary from minus 1 to 1. So if that is the case, so we can just use Gauss 2-point formula. What is Gauss 2-point formula? So let's go back to the notes. Let's see. Gauss legendary 1-point, and you have 2-point formula. The 2-point formula, the final, we can also derive it, but I'm just going to skip it. The final formula is something like this: minus 1 to 1 f of x is f of minus 1 by root 3 plus f of 1 by root 3. This is equal to f of minus 1 by root 3 plus f of 1 divided by root 3. Okay. Now we know the function. We just need to evaluate that function for minus 1 by root 3 and 1 by root 3. So the function is 1 divided by 1 plus x square, and f of minus 1 by root 3 is going to be 1 divided by 1 plus minus 1 by root 3 square. It's going to be 1 divided by 1 plus 1 divided by 3. Okay, this is going to be 3 plus 1 4, so it's going to be 3 by 4. Okay, similarly if you can do for f of 1 by root 3, and since there's a square, I think it's going to give you the same answer. So again it's going to be 1 plus 1 by 3, which is 3 by 4. Okay. um all right, let's substitute it. I is equal to 3 by 4 plus 3 by 4, which is 6 by 4, which is 3 by 2, is equal to 1.5. So your answer is 1.5. Okay. But you also want to know how much what is the error this has, right? This function we can integrate it. Let's try to integrate it. Second. All right, let's try to integrate that function. Integral of minus 1 to 1 f of x dx minus 1 to 1 1 divided by 1 plus x square dx. So what is this formula? How will you integrate this?
Tan inverse of x.
Right, tan inverse. Wonderful. So this is nothing but tan inverse of x evaluated at minus 1 to 1. Okay, and this becomes tan inverse of 1 minus tan inverse of minus 1. And when you are using calculator for this, please make sure you are using radians. Okay, so what is this coming out to be? Tan inverse of 1 is something like 0.7854, and tan inverse of 1, sorry, tan inverse of minus 1 is minus 0.7854. Okay, and this comes out to be 1.5708. But what you found out using the Gauss 2-point formula is 1.5. Okay, so the associated error is nothing but 1.5708 minus 1.5, which is 0.0708. This is your error. Maybe if you use Gauss 3-point formula, you might have better results. Maybe should we try? Maybe we should try. I haven't tried. Let's try Gauss 3-point formula. I is going to be, what is our 3-point formula? This one. Okay, you have 1 by 9 phi 1 by 9 phi f of minus square root of 3 by 5 plus 8 f of 0 plus phi f of square root of 3 by 5. Okay, let's find out f of minus square root of 3 by 5, which is going to be 1 divided by 1 plus minus square root of 3 by 5 square, which is going to be 1 divided by 1 plus, how much is this? 3 by 5, which is going to be 5 by 8. I think this is what is going to be for f of this is also same as f of square root of 3 by 5, because x you substitute there is in square, so whether it is minus 3 square root of 3 by 5 or plus square root of 3 by 5 doesn't matter. And you also need to find out f of 0. F of 0 is simply 1, so let's substitute it in the integral. I is equal to 1 by 9 5 times 5 by 8 plus 8 plus 5 times 5 by 8. How much is this? 1 by 9, 25 8 by 8, 25 by 8, 50 by 8 plus 8. 50 by 8 plus 8 divided by 9. So you have 1.5833. Okay, so now let's find out the error. So the error is 1.5, what is it? 1.5708. 5708 minus 1.5833 is minus 1.5708 is 0.01. 0.25. So this is much lower than Gauss 2-point formula. So as you increase the number of points, you're going to get more closer to the results. Okay, so your error continuously reduces. All right, again same, like substitute in the formula whatever they ask for, you will end up having your results. Okay, I hope there is no question. Let's do the final problem. Here we are going to use again Gauss legendary 3-point formula, but the integral is not varying from -1 to 1. That is the difference. And also, you know, we will try to find out, the integral of this. Let's first, do for Gauss legendary 3-point formula. So your function is e power minus x square, and your integral you're trying to do is from 0.2 to 1.5 e power minus x square dx. Okay, first thing is you cannot apply legendary Gauss legendary formula because the interval does not vary from -1 to 1. So what you need to do, you need to apply transformation. So transformation you have to do to change these limits from 0.2 to -1 and 1.5 to 1. Okay, so what is the transformation? We actually saw one of the transformation to be x is equal to half of b minus at plus b plus a. So in your case, a is 0.2 and b is 1.5. Okay, now let's substitute it. So x is equal to half of b minus a is 1.5 minus 0.2 is 1.3t plus b plus a is 1.7. Let's simplify this further. It's I think 0.65t plus 0.85. So your transformation is x is equal to 0.65t plus 0.85. Now, what is your dx? Your dx is going to be 0.65 dt. So instead of dx, you have to substitute 0.65 dt, and your f of x is going to be e power minus x square. That is going to be e power minus 0.65 t plus 0.85 square. Okay, now let's write down the integral. I is going to be integral of 0.2 to 1.5 f of x, where f of x is e power minus x square dx, which is what we need to find out. This is equal to integral of e power minus 0.65 t plus 0.85 square into dx. Dx is 0.65 into dt. Okay, now what will be the limits? The whole point of doing this transformation is to change the limits uh, from 0.2 to 1.5 to -1 to 1. Okay, and you can also substitute your 0.2 here. So for example, let's say you put 0.2 here, and you can find out what is t. So 0.2 minus 0.85, 0.2 minus 0.85 is minus 0.65, divided by 0.65 is -1. So your t is -1. Similarly, you substitute 1.5 here, you will end up t to be equal to 1. Okay, so that's the point. So that's why we do this transformation. So now your integral has become integral of -1 to 1 g, let's say another function g of t dt, where your g of t is now 0.65 e power minus 0.65 t plus 0.85 square. Okay, so now we need to apply Simpson 3 by 8. Is it 3 by 8? Did they ask? Oh, sorry, not Simpson. Gauss legendary 3-point formula for this function. Okay, which is, what is Gauss 3-point formula? I is equal to 1 divided by 9 5 times f of minus square root of 3 by 5 plus 8 times f of 0 plus again 5 times f of square root of 3 by 5. So this is your integral. Oh, okay. Now since we transformed our function from f to g, we also need to write this integral function in terms of g. Okay, please don't get confused. Okay. Now we have the functional definition of g. We can easily find what are these values at minus square root of 3 by 5 and square root of 3 by 5 and also at 0. So let's find out that g of minus square root of 3 by 5 is equal to 0.65 e power minus 0.65 into minus square root of 3 by 5 plus 0.85 whole square. Okay. How much is this? 0.65 into square root of 3 by 5 into plus 0.85 square e power minus 0.1201. Okay, now if you substitute it, exponential of answer 2.65. This is something like 0.5764. Okay, this is g at minus square root of 3 by 5. We need to find a g at 0. I mean t at 0. So g at t at 0 is minus 0.65. This is 0, so it goes away, plus 0.85 square, which is equal to, what is 0.85 square? So this is 0.65 exponential of minus 0.7225. So exponential of minus 0.7225 into 0.65 is 0.3156. Okay. Now we also need to find square root of 3 by 5. This is 0.65 e power minus 0.65 square root of 3 by 5 plus 0.85. There's a multiplication here into square is equal to 0.65 e power minus 0.65 into square root of 3 divided by 5 plus 0.85 square. This is coming out to be something like 1.8319. So the total is e into 0.65. Okay, this is coming out to be 0.1041. I hope these numbers are right. Anyway, we'll cross check from analytical solution if something exists for this. So let's do it. I is equal to 1 divided by 9 times 5 times the first point, which is 0.5764 plus 8 times f of g of 0, which is 0.3156 plus 5 times 0.1041. Okay, now you can simplify this. And let me know the answer if you have. 8 into 0.3156 plus 5 into 0.104 divided by 9. Okay, I'm pretty fast now. So it's I to be 0.6586. Okay, this is what I'm getting. So this is so basically what I'm saying is I, which is equal to integral of 0.2 to 1.5 e power minus x square dx, which is equal to minus 1 to 1 0.65 e power minus 0.65 t plus 0.85 square dt. Both of them are equal to 0.6586. Okay. Now let's see how close this value is with the analytical solution. Let's say if you want to directly integrate, how will you do it? Integral of 0.2 to 1.5 e power minus x square dx. How do you integrate this? Actually, we don't have any method to integrate this. This is a special function, and it does not have an antiderivative. Or so what does it mean is you do not have a function whose derivative can be regarded as a integral. Okay, so this is actually uh, called as error function. So for example, we have something called integral of e power minus x square dx. It's nothing but uh, I guess it's square root of pi by 2 error function of x, and there is no explicit definition for error function of x. Okay, so when you are in this kind of position, let's say your equations turned out to be something like this, then you will end up having uh, problems like this. Other time you can rely on numerical methods. You can use we simply applied this because 2-point formula, and we within a matter of seconds we got this, provided they have given definite integral. um, it will be a little bit messier if you want to do it in analytical. So for example, let's say if I substitute this, um, so this I can write it as this is square root of pi by 2 error function of x into 0.2 to 1.5. Your calculator will not have error function. Maybe if your calculator is bit advanced, you might have error function, but you do not have an explicit definition for error function. It will be like this integral. Okay, so now if you substitute this is going to be square root of pi by 2 error function of 1.5 minus error function of 0.2. So I have substituted this, and I used to Google for answer. So if you evaluate the error function at 1.5 and 0.2, your calculator cannot do it. So at the end you will end up having 0.6588. Okay, this is your true solution. True solution or true value, whatever it is. So now error associated with the Gauss 3-point formula for this problem is, what did we got? 0.6586, 0.6588 minus 0.6586. So this is like 0.0002. Okay, this is your error. It's not that big of a difference. So um, so it's you can easily come up with an estimate by just doing this integral. Okay. All right. Any questions? I hope this will be helpful for you to solve this week's assignment. I covered as much as possible. So, for example, what is the results we got? 0.6586. I hope they are, yeah, 0.6586. Okay. All right. Thank you, Damodaran. Also for stopping me from applying Simpson's 3 by 8 rule for the first question. For some reason, I lost
Oh,
this first. I will redo it in the first and then I will put it here. How do I go back?
I accepted that remaining excellent teaching, sir. Nice explanation step by step.
Oh, thank you, Damodaran. So,
Thank you, sir. Thank
thanks
you.
for the compliment.
Thank you, sir.
All right. Any questions you guys have? This week, I guess all the problems are very easy. Just need to apply formulas. All right. If there are no questions, then we will conclude our session here. But anyway, I will stay back till 6 in this meeting link if anyone wants to ask any questions. If not, we will meet in the next class. Okay. So next class, I think it's going to be about ODEs, how to numerically integrate ODEs. Okay. All right. See you in the next class. Thank you for joining today. If you have any questions, you can stay back and ask. Okay.